Two similar rectangles. Now, I'm going to work out the length scale factor, just as we've done in the previous video. Why don't I have calculate? Well, I'm calculating the scale factor for enlargement, so 20 over 10 gives us a scale factor of 2, which is to say we multiply the smaller shape by 2 in order to get the larger shape. Now, what I'm going to do next is to work out the area of both shapes. Well, the area of a rectangle is length times breadth, so the area of this shape, 6 times 10 is 60 centimetres squared. Area 2, this one's a bit trickier, 12 times 20, 12 times 2 is 24, and add on a 0, that gives us 240 centimetres squared. Now there's a reason for me doing this, because we're moving on from length scale factor to area scale factor. So, the area scale factor for enlargement, we're going to use exactly the same formula, final over initial. The final area is 240 and the initial area is 60, which gives me a value of 4. Now, why have I done this? Well, what I want to do is to find a connection between the length scale factor and the area scale factor. The length scale factor has a value of 2, the area scale factor has a value of 4. How do we get from 2 to 4? Now, well, I suppose we could multiply by 2, but that's not the correct answer. The correct answer is that we square 2. It has the same effect with the number 2, but not with other numbers. So, what do I want to state? I want to state that the area scale factor is the length scale factor squared. And we can also state that the length scale factor is the square root of the area scale factor. And we're going to be using both of those formulae in the following videos. Example 1. We're told that the shapes are similar. That's very important. If the shapes are not similar, then we cannot proceed. Now, what else? We're told that the area of this shape is 750 centimetres squared, and we want to work out the area of this shape here. You may be saying to yourself, we've only got one dimension, we've only got the length, so how can we calculate area? Well, we've seen that there is a connection between the area scale factor and the length scale factor. To calculate the length scale factor, we really only need one side in each shape, as long as that sides correspond. So 30 over 12. 30 over 12 is divide top and bottom by what? 6. So that gives us 5 over 2. Now, the area scale factor is the length scale factor squared. That's to say we're going to square 5 over 2. How do I? Well, if I square 5 I get 25, and if I square 2 I get 4. What does this mean in the context? It means that I multiply the area of the smaller shape by 25 over 4 to get the area of the larger shape. So what am I going to do? 25 over 4 times x, which is the area of the smaller shape, will give me 750 centimetres squared. How do I deal with something of this sort? I'm going to multiply by 4. So 25x equals 4 times 750 is 3000. I'm going to divide by 25. And that gives me 120 centimetres squared. Here's a problem involving triangles. So let's work out the length scale factor. Nice and simple, this one. So the length scale factor, and we'll work out enlargement. Final over initial, 14 over 7, which is 2, so we don't need to worry about fractions. Now, the area scale factor is the length scale factor squared. 2 squared is 4. What does that mean? It means that if I multiply the area of the smaller triangle by 4 in order to get the area of the larger triangle. So, proceeding then, we know that the area of the smaller triangle is 20 centimetres squared. So the area of B is 4 times 20, which gives us 80 centimetres squared. Third and final example involving similar areas is interesting. Now, you'll notice that we have the area of both shapes, but we're missing a length. Now that's interesting, because normally we would work out the area scale, the length scale factor first, but we can't do that. What we can do is work out the area scale factor. And we can work out the area scale factor for enlargement or reduction just as we please. It's final over initial, as it always is, and the larger area is 36, the smaller area is 25. Now that number does not simplify, we cannot cancel down. You may remember in the very first slide I gave you a formula which was that the area scale factor is the length scale factor squared. I gave you a second formula which is the one we're going to use now, and that's that the length scale factor is the square root. Let me just change the order. So if I square root the area scale factor, I get the length scale factor. And that's what we're going to do just now. So the length scale factor for enlargement is the square root of the area scale factor. The square root of the fraction 36. Now, the square root of 36 is 6. The square root of 25 is 5. So lo and behold, the scale factor for enlargement, the linear scale factor or length scale factor for enlargement is 6 over 5. What does that mean? It means that I multiply each length on the smaller shape, each length by 6 over 5, which is an awkward fraction. We'll see how that works out. So that means that 6 over 5 times 2, that's the smaller length, equals x. 6 over 5 times 2 is 12 over 5, and 12 over 5 is 2.4 centimetres.